Okay, so hi everyone, thank you for joining my session. My name is Nir, I will introduce myself later. I'm from LivePerson. I have 2 comments about the slides. So first of all, most of the things might be obvious to you, so you might be familiar with most of the topics that will be presented here. And the other issue that I have something around 80 or 90 slides in this presentation, so it should keep you up and running in my session. I'm not going to talk about more than 30 or 40 seconds for each slide, so it's much easier. So first of all, I'm Nir Koren, I'm from LivePerson. I will introduce the company later. I'm located in Israel. I've been doing DevOps for more than 10 years. I've been working for LivePerson for 2 years and previously worked for SAP for 9 years. There's the details if you want to contact me or follow or whatever. Today we're going to talk about LivePerson. I will introduce the company, and after this I will introduce the production because this is much more interesting. I will talk about the CICD processes in LivePerson. I will do some drill down into the CICD because this is kind of mandatory steps in order to understand the deployment processes. I will talk about the D6R, which is the deployer. Okay, D6R mean the 6 letters R, like internationalization, which is I18N, if you're familiar with it. This is the way we called it, like AATs for Kubernetes. So I will talk about the LivePerson deployer. I will talk about the technologies that we developed this deploying tool and the impact that this deploying tool did for the entire company of us. So let's talk about LivePerson. Is there any chance that any one of you heard about this company? Okay, no. Okay, so we are existing for more than 20 years. This is an American company. This is a 100% software as a service company. We founded in 1995 and the headquarters in New York. This is an American one. We are also in NASDAQ, LPSN. We have about 1,100 employees, and we spread all over 12 offices all over the world. We have also office in Mannheim for 15 or 20 people in Germany. We have something around between almost 20,000 customers, and we are running 27 million interactions per month. I will explain it later. LivePerson, it's actually a company that develop messaging services between customers to providers, and it's actually the mission is to make the life of the customers easier by transforming from voice messaging to chat and text messaging, and actually want to eliminate the 1-800 number. So our product is actually running on each device, mobile, tablets, laptops, whatever, and you can connect your customers by the chat or by the messaging systems. Probably you might use our product somewhere if you talk with your mobile provider customer service or your bank. We're a lot of customers that actually use our product from these sectors. Actually, LivePerson founded on the fact that people are no longer called, they text their message. They don't want to wait for the customer service on the phone. They prefer to text and get the message and the answers later. So if you see the graph, it's quite the fact that phone calls become less and less popular, like text and messaging. Started from the SMS, through the WhatsApp, Viber, Snapchat, whatever you use. It become more and more popular. And this is actually our product. Just very in a nutshell, our product is actually based on agent screens, campaign screens. It's called Live Engage, so we have dashboards, BI dashboards, and reporting, and everything that a customer service can be managed by a company in front of her customers. We have a lot of customers, big brands. You might know most of the logos here, but actually this is the mission, to move people from voice call into messaging. We also, some of the customers are behind the scenes of Facebook chats, Apple Business Chat, and so on. So this is just an introduction about LivePerson. If you want to learn more, feel free to go to our website and get some more information. If you have any questions, you can just follow me later. I'm here until tomorrow evening. So let's talk about LivePerson production. So we are quite busy. We have 7 worldwide data centers all over the world. We are running 10,000 servers, both virtual and physical. Of course, that 99% of the servers are virtual, and this is actually VMs. Of course, we are running some containers and Docker and Kubernetes, but we are talking about 10,000 VMs that's running in LivePerson production data centers. We are dealing with 3 million concurrent visits at the peak. When I say peak, I mean Black Friday, for example, or Cyber Monday. We are getting into 3 million concurrent users on our systems. We have 1.1 metrics that we are monitoring per minute with the monitoring system that we have. We have 3 billion visits per month on our chat systems, on our messaging systems. And of course, we have 7,000 production deployment per year. Okay, I will talk about the technology and the microservices later. But we are quite busy. We are holding 4.5 petabytes of data, and we have NOC, Network Operations Center, that monitor the entire monster 24/7 as it's required in such a large, massive traffic. So we are quite spread all over the world. The data centers are in the US, in Auckland and Virginia. We have it in London, in Amsterdam, in Tel Aviv, and in Sydney and Melbourne. So we quite covered all over the world for our customers. So our architecture is based on MSA, Microservices architecture. Any of you attend yesterday after the beer, so I presented the pasta in a different presentation. But anyway, just to make an alignment, when we talk about microservices, it's actually moving from the monolith, and we did a transformation 3 years ago. So it's running from the monolith into a microservices. If we take the pasta, for example, so we are moving from the entire plate of the nice pasta dish that it's currently presented here in the presentation, and we split it into the components. And let's say I want to replace the garlic in onion or something else, or remove the entire basilicum or whatever. So it's very easy for me to do it. It's supposed to be very easy, but this is what we are aiming for. And of course, if we talk about our microservices, we are holding something around 200 microservices. We actually have a single product, but we have actually, in fact, 200 products, minor products that's running in our side, inside our company. And each product is actually represented by code repository. It has its own code repository, has its own life cycle. Some of them we're deploying once per a month or once per 2 months, and some of them we're deploying once in 2 days. It's very dependent on the service. So each one has its own life cycle, its own requirements. Its own deployment rules. Some of the services we're deploying in production is secure, and some of them we are deploying in the PCI, which is the most secure environment for production. Each service from the 200 services has its own VMs or its own containers, its own environment, and of course it provides the needed API and the entry points for the other services. Let's talk about the CICD processes in LivePerson in order to manage those 200 servers and this huge traffic. So we are doing 7,000 deployments per year. When I say deployment, I mean production deployment, productive deployment, and we're affecting almost 20,000 customers and millions of users. We have almost 2,500 active GitHub repositories. We are holding an instance of GitHub installed in our location, GitHub Enterprise. And I'm not talking about forks. I'm talking about only repositories. We are having something around 15,000 weekly builds that are managing and running on those systems, whatever it's CI builds, scheduled builds, or whatever. Our main orchestrator, we'll talk about it later, it's TeamCity, and we also use Jenkins, and on top of Jenkins and TeamCity, we are holding something around 80 build agents, and everything is running by 30 Scrum teams that are developing. We are about, in the R&D, we're about 400 people from the entire company, so we are actually running the entire monster. Okay, let's do a drill down about the CICD. Of course, if you have any question about our CICD or our tools, feel free to contact me after the session. So the developers work on Git, like I think most of the people here working on Git, and everything is running on Maven. We're trying to put each service in its own standards. So we're quite providing a Maven plugin in order to make everything unified. So we provide some artifacts that create Maven skeleton with the Puppet deployment and the Docker stuff if needed. So everything is actually orchestrated by our archetype. And we use also NPM, and this is something that we are trying to remove out of the Maven because it doesn't make sense to run NPM builds inside Maven, but we are trying to remove it out of the scope. But this is ongoing process. Everything in our CI/CD is orchestrated by TeamCity. Historically, we started with TeamCity, and if you know, it's very difficult to start moving services, but we're quite happy with TeamCity. It makes a lot of sense, and it can deal with a large traffic of builds and high availability. So TeamCity is orchestrating the entire CI/CD. So what happened when the developer put a change in the Git is actually putting to the enterprise GitHub server that we are holding inside our company, and TeamCity is starting to trigger the entire cycle of the CI process. So the first step after it builds and runs the unit test like we do normally in Java. I didn't talk about the technologies, but the server side, it's mainly in Java. We have also some builds of big data. We use Hadoop, and we also have some client-side stuff because the entire client is based on libraries of JavaScript and NPM, Node.js. So when you run the build, it's actually deploying the artifacts to the Artifactory. And then we create the RPM. So we wrap our code into our RPM and upload it into local YAM repositories. And after this, when we start the deployment, everything is running on Puppet. We quite called ourselves Puppet Shop. So everything is running on Puppet. And the Puppet is actually triggering the deployment by the rules and running the deployment from the RPM to the relevant servers. And of course, the servers are actually maybe VMs based on our internal OpenStack installation or our VMware. It depends on the service and whatever it's been defined. And after this, we can start doing some tests, some Selenium tests, some checkmarks, scans, checkmarks, and SonarQube and WhiteSource. Anyone familiar with WhiteSource? No one. Okay, it's actually a cloud product that it's a competitor of Black Duck. It's scanning dependencies based on the rules, on security issues, on licenses issues. It's mainly for legal reasons, but the checkmark, SonarQube, and the WhiteSource, we are scanning on a release build or on a nightly build. And in this way, after everything has been scanned, the artifact is being published and can be deployed manually by the QA for the QA environment. If he wants to deploy it, We are starting to move on a process that automatically it will be deployed, but as you probably know, it might be difficult when someone is in the middle of test and its system is being deployed continuously, and it doesn't make sense to keep it inconsistently state. So this is one part of our product, and the other part, if you're looking on the middle of the area, it's the Docker and Kubernetes build. We are starting to move from the Puppet into the Docker and Kubernetes, and more servers and services are being transformed from the old known Puppet RPM into the Docker and Kubernetes. So if I'm looking at the same graph, the only change is only in the middle of the area, which is here. So when we run the build, we actually create our YAML files. Based on the YAML files and the Docker stuff, we're uploading it into the Harbor Docker registry. Any one of you heard about it? Okay, only you. So Harbor, it's open source provided by VMware. I truly recommend to use it. It's very easy to install. It has a nice UI, and it's free. Unlike Artifactory or Nexus, which you have to pay a lot of money in order to make it as a Docker repository. Harbor, it's based from VMware, and it's free, and it's open source. So we use it. We use it also for production. And of course, everything, when it's uploaded successfully, we're deploying the stuff into the Kubernetes. Unfortunately, we are holding an internal cloud, so we are not using Amazon currently, or Google, or Microsoft, because our customers want the data to be kept in our servers. And after the same stuff goes here, scans, checks, and publish for deployment to QA and to production. So what is the release process? How do we release services as soon as they're ready? How do we release it to production? So when the deployer, when the developer want to release, he release it on his own. It's just triggering a build manually. It's doing by itself. And when the release build passed, the artifact is actually moved to a release repository. If we are talking about RPM, so we have a dedicated RPM repository for release, or we have dedicated Docker registry for release. And as soon as this issue is being released, there is a certification process that I will talk about it later. But as soon as the artifact has been certified, it can be exposed to the production environment, and the data centers can see only the production environment. So each microservice has its own release process. The release process is identical to all services. And as soon as the service is in production, the deployment tool to production can see the service, and the service can be deployed. So how do we make, I talked about it yesterday a little bit, but how do we make a unified process for all services? So we have a parent POM in Maven, and in the processes are being, the data and the properties are being kept in the parent POM, and each service must inherit the parent POM. You won't be able to release technically if you are not inherit the parent POM of LivePerson. And when you inherit the parent POM of LivePerson, you will be able to release. So in this way, we can keep everyone on the same page. We can keep that everyone are using the same information for release, the same release properties. We're doing the release technically by the Maven release plugin, which is quite straightforward. And as soon as it's released, we can just continue with the certification process. So what is the certification process? We have a deployment tool. We have a promotion tool. And the promotion tool, it's actually taking the stuff from the release repository into the production repository. And the production repository, as I mentioned, is the only repository that the production environment all over the world can see. The production environment cannot see the CI or the QA or the release repository because they are inside a LivePerson network. So the certification, it's actually a process. It's actually a tool. When someone wants to deploy something, you just mark the service name and the service version that you want to deploy to production. You press the button, and there is approval processes. It's actually kind of a stamp process where the QA manager or the QA lead marked his stamp as approve the process, and the PMO approved the process, and everyone who needed to approve the process make this stamp on this application, and as soon as everything is marked, the process, the promotion is being promoted from the release repository into the production repository. And as I mentioned, the production repository, it's available to all data center on all farms all over the world. And this is the only repository that they can see. So a little bit alignment. I'm sure that most of you know the difference between continuous deployment and continuous delivery. So if we are talking about build, deployment, some tests, some code scans, and deployment to production, on continuous deployment, everything it's been done automatically. So when the developer pushes the code into the source code management repository, we expect that after, I don't know, 30 minutes, 1 hour, 2 hours, the customer will be able to see it automatically without anyone touch this process. And continuous delivery, it's quite the same, except the production deployment is being performed manually. And this is the difference. When you say CD, it means deployment and delivery, but when you say deployment, it's automatically, and delivery, it's manually. The process of deployment to production, it's manually. And in our case, because we have the promotion process and the manual press button that we are doing the deployment, that I will talk about it later about the D6R, we are running actually continuous delivery. So, as I moved along the slides and brief about the CI/CD processes, it looks like the LivePerson developers are on the entire process from the IDE to release. Means that it's kind of almost pure DevOps, but it's not 100% correct. Since we provided the tool, the developers are responsible for the entire process from the IDE to production. So in this case, when a product owner opens a backlog item or a task or a case or a user story or whatever, and they want the developer to develop a feature, unlike the previous state when the developer pushed his code and marked the backlog item in Jira as done, now the developers are marking the backlog items in Jira as done after it's up and running in deployment, in production. So the developers are actually on the entire process. Okay, so after briefing the CI/CD and the release process, let's talk about the deployment, the deployer tool that we developed inside our company. So when you provide a tools or when you provide the processes, you wonder sometimes if your developers or your customers, internal customers, will use this tool. And there's, you know this movie, right? Most of you? Did you see it? Anyone? Did you see this movie? Okay, Field of Dreams. If you build it, they will come. So if you provide the tools and you believe in these tools and the processes, we can expect the developers that they will adopt it. So when we developed our tool, we had some goals that we defined. What are the goals to have a production deployment? So the first goal is to keep away the developers as much as we can from SSH. I mean, for example, you can provide your developers an SSH login, and it's very common. Most of the companies say, hey, we are doing continuous deployment or continuous delivery, and our developers have their own access to the production environment. We gave them SSH, we gave them sudo permissions, but this is very dangerous because when you provide the root permissions to the developer, it actually can can do some wrong, and I'm sure most of us had some bad issues unexpectedly and not on intention. But we want to keep the developers out of the production, out of the SSH login. We want to give them a nice UI in order to make the deployment. So this was the first goal. The second goal by the way, this is the first time I'm in Munich. I was, I think, more than 20 times in Germany, but this is the first time I'm in Munich. And in this time, I couldn't find a ticket to Bayern game, because there is no game currently, unfortunately. But the second goal is to defend the production, to defend the holy production, to make people not doing harm and keep it as much as we can stable. The second goal is break the annoying bottleneck. When we have a deployment team, and this was the previous state, we had a deployment team that managed the entire process. So when a developer wanted to deploy something, he just asked the deployment team to make this deployment for him. And it was a quite bottleneck, because when you have 200 microservices and we have a deployment team of 5 or 4 people, sometimes when you request a deployment, you can wait for 3 or 4 days until those guys will be able to do it, to reach into it. So we wanted to break this bottleneck. We wanted to move from a tool that everyone can use it and break this entire bottleneck that it's normally common when you have a deployment team. And the goal 4 is to give power to the people. I mean, they are the developers. They know the code in the best way. They can own the code in the best way, and give them the power to make the deployment. And I think this is DevOps is all about, if you ask me. Goal number 5, it's make everyone fully committed. When you hold the deployment team and you say to the developer, hey, this is out of your scope, I mean, you can develop your stuff, and as soon as you finish the development, I will do the deployment. It's actually not fully committed, as you know. It's not fully committed to the runtime in production, and this is the main known problem that dev and ops are usually blame each other. So if you provide the developer an access to make the deployment in production, it's fully committed to the entire process. So when we try to think about who should make the deployment in production, we had the deployment team. We call it ops team or deployment engineers. And we have the developers. And we have pros and cons if you provide the developers of the ops team the permission to make the deployment. So if we take, for example, the production engineer, so he is fully controlled on production. I mean, this is his job. He comes to work on a daily basis, and he knows the production the best. He has full control of the services and the processes. He has experience with the production environment, and he knows the best how to troubleshoot issues. He knows how to get into the logs. He knows exactly the pain points, and it can be the main focal point for any issue that might be appeared. When you give the production DevOps the permission to deploy, we have also some cons. So as I mentioned previously, it's a bottleneck. When you have a lot of requests, you cannot deal with all requests at one time. And it's not really a time saver for the development. I mean, when you say the production, the developers shouldn't make the deployment, so you think it might be save some time, but it's not a time saver, because the production engineer, when we make the deployment, he asks the developer, hey, can you check the application for me? Can you check if it's up and running properly? Because it's not familiar with the feature and the bits and the bytes. And of course, developers are not accountable for the entire process. When someone else do the job for me, I don't care about it. So we thought, okay, so the developers should make and this is basically the current state. So the pros, of course, the developer takes full ownership and accountability to the process. He knows his feature the best. He knows his feature more than the deployment engineer, of course, because he developed it. He can deploy whatever it needed without using an on-call function. We had some issues that on Friday night or Saturday night, we had to provide an hotfix. So the developer actually developed the hotfix and make the release and make the approval and put the binary into production. And then we have to find out the on-call duty person who will make the deployment for us. And it's actually a waste of time. And the cons, of course, when a developer make the deployment, and there are some cons, so it's not always understand the entire production environment. It's not his area. This is not his job. He's not aware of issues that might be appeared. He has no experience with the entire integration. I mean, hey, I care about only my process, only my service, and I don't care about the rest of the services, maybe because I'm not familiar with it. And he can't go wrong with troubleshooting. If needed, he needs to log in. He might be delete some unneeded stuff. So the deployment team actually served the entire R&D. This was the previous state. And if we change the words a little bit, so the ops team served the entire dev, and dev started to take ops tasks. And this is actually a DevOps. So what is the deployer, the D6R? It's actually a secure, safe tool, which is transparent. It's a self-service deployment tool, and it provides flexibility, transparency, empowerment, and efficiency to the developers. It's quite a huge words, but I will talk about it later. So before we developed the deployer, how did we deploy to production? So it was quite easy. We had an ops engineer, and we have two main servers that can connect to the entire production environment. One of them was PCI. You familiar with PCI? Anyone of you heard this terminology? Okay, PCI, it's a more secure environment to production. I mean, everything is secured, but it's extra highly secured. It depends on the services. If you're holding sensitive data or something like this, it might be more secured. So we had two servers, and one of them is the secured, and one of them is the highly secured. And those servers had access to the entire data centers all over the world. We had some deployment engine, which is based on Ruby, command line tool. When the deployment engineer wants to deploy an old system, he just typed the command, and behind the scenes, there was some puppet that ran and deployed the stuff to him, or Kubernetes and Docker commands that they deployed to Kubernetes. So, as I mentioned before, those two servers, the PCI and the normal servers, actually provided for the deployment engineer authentication and authorization. Okay, I can authenticate and get the relevant authorization rules for my deployment. I could get from those servers worldwide into the whole farms, the whole data centers all over the world. And it was a single point of access, means that I don't need to remember how do I log into Virginia or Tel Aviv or London. And I didn't have the necessity to log into each server. It was a single point of truth. And of course, we had a classification and restricted and highly restricted, which is the PCI and the normal secured login. And of course, the deployment engine, it's an in-house deployment. It's an orchestrator tool based on Ruby, as I mentioned. And it's scriptable, it's open, it supports rollback. I mean, if I deployed something and I want to go back, I don't have to remember what was the previous version. I just type rollback and it goes back to the previous version. And it can run both on Puppet and Docker and Kubernetes. It's identified the servers based on this definition, and it's very easy. So, where did we put the D6R, the deployment tool that we developed? We decided to keep the environment as is because it's working, and we decided to put it between the engine and the PCI. So if we are running on any servers, we would run the deployment tool on those servers, and it will be actually the controller. I will explain it about later. So when we decide to go over a deployment tool, we had a lot of options. When you decide normally to implement a new tool in your organization, you can use proprietary product, you can buy it, you can use open source, which is, from my point of view, the most recommended way, or you can internal your own development. And of course, we have pros and cons for each process. So we try to explore and think about how do we implement a tool, what should we do, how do we get it, how do we get a deployment tool. So we try to think, okay, let's see if we can buy something. So what is the process of buying a product? You actually get the features, bug fixes. It's easy to implement. There's a great documentation. You got the best support when you buy a product because you pay for your support. But of course, it's expensive. It's not flexible. You buy it out of the box product and you're not able to make some changes. It's a closed product and it's actually tied you up. I used to work for SAP, and the company that implements SAP will stay forever for SAP. I don't know if you know about it. But it tied you up with the product that you implemented, and you will pay for a license for the entire life. So we checked about open source. So open source, it's free. It's supported by the community. If it's popular, you get a lot of bug fixes and a lot of updates. And it can be also contribute. You can contribute if you did some amazing stuff that you develop amazing process on top of this open source. You can contribute it to the community. But it might be too open. It might be insecure sometimes because the developers of the open source sometimes intentionally or not intentionally put the backdoors in the product. So it can die one day. I mean, we have a lot of examples of open source that someone make the fork. For example, Hudson. I mean, it's still being developed, but no one uses Hudson, right? I hope. Okay, so, and it required legal attention. When you implement an open source and you work on a large company, sometimes it might be a headache with the bureaucracy to get the legal attention and the legal approval to use this open source. And I'm not familiar with the GPL and the licenses. I just heard about it. I'm not going to read the entire agreement. No one's do it. It's quite headache. The best way is to developing. It's also an option. You can develop your own process. You can develop it. You can get some developers and put them, close them in a room and say, hey, guys, do my tool. So it will be exactly what you want. Everyone will support this tool. The one that developed this tool will be able to provide bug fixes and features, and it will also fulfill the organization requirements. For example, if your organization requires kind of using in a special UI that's unified for the entire organization, it will be much more easier because your developers will do exactly what you want. But of course, it takes time. It takes a lot of time, and it requires expertise. And it's expensive because you put out the developers from developing a new feature to your product into the development of internal tools. And of course, like everything else, it requires maintenance. So when we decided which way we should go, we defined the deployment tool. What do we want the deployment tool to be? We want it to be robust. We wanted to have an authentication and authorization. It's very important. We wanted to keep it free and open source. We didn't want to pay for it. And we wanted to be popular, because when you use a popular open source, you get frequent bug fixes and features. We want to do it fast. We want to be within 2 months from the idea into the production, into the productive usage of the developers. And of course, we wanted to have it user-friendly to make the developers want to use it. So we thought about it, and we had a lot of discussions. So what was the best way to combine all needs? And we came to the conclusion that Jenkins will do the job. So, as I said at the beginning of the presentation, most of the slide will be obvious, and I'm sure every one of you heard about Jenkins and working on Jenkins. So it's a platform. It's not a tool. It's not a software. And if any one of you were in Jenkins user conference and met Kosuke Kawaguchi, which is the owner and the inventor of Jenkins, and will tell him that this is a tool, I'm not recommending. So actually, it's open source. It's very easy to install. It's very easy to use. It's very, very easy to implement plugins. So when you use Jenkins, for example, you can use the authentication and authorization. You don't have to develop it. You just install the relevant plugin or use the out-of-the-box plugin that comes with Jenkins, and you get the authentication and authorization. And it can be authenticated against your organizational LDAP. It can be authenticated against the GitHub. If you have a GitHub user base, you can just manage it and connect it via Jenkins, like everyone do it on Facebook. For example, a lot of websites. I'm not sure that Jenkins support it yet. You can make a SSO with SAML. And also, you can hold your internal local user base inside of Jenkins, and each user can own its own permissions and authorizations. It's an open platform. We have more than 1,000 plugins, and it's growing. And it's open. Everything you see in the UI, you can do by the API. You can do it by the JSON or the XML, whatever you prefer. Everything that you see in the UI, it's visible when you put /API XML or /API JSON. You can see the entire view in the relevant data that you just choose. Does any one of you have an experience using the API of Jenkins? Okay, so it's very easy to use it. And of course, it's extendable. I mean, if you want something that it's, let's call it a boutique plugin, you can just develop it. It's very easy, especially for Java developers. It supports Groovy and DSL. And Java developers feel very happy working with Groovy. So you can just extend it and put a lot of behaviors with Groovy. And of course, it supports the declarative pipelines. I will just drill down a little bit about the pipeline, but it's actually pipeline, it's declarative job as a code. So you can just code exactly what you want the job to do, put it somewhere in your source code repository, and call it by the Jenkins job. And you can do the build, the test, and everything based on the pipeline. And of course, Jenkins is popular by the community. And when it's popular, you get the benefits of bug fixes, upgrades, features, security updates, and so on. And of course, if you use Jenkins and use it as a platform, your development will be in short time because you don't have to waste time of developing authentication and authorization mechanism. You don't have to deal with the UI, even that the UI is quite crappy in Jenkins. Okay, it's not the nicest UI you can find, but you don't have to waste time for it. You get it out of the box. So what technologies did we have in the DSXR, in the deployer tool? Okay, we are running it based on Jenkins, and we are running it based on Groovy script. So the deployer, it's actually the Jenkins, the jobs that comes from the Jenkins. They're triggering the deployment engine. And everything that runs based on Puppet or Kubernetes and Docker, it's holding in GitHub. If you use Puppet and RPM, so you will hold the manifest in GitHub. And if we use Docker and Kubernetes, we will hold the YAML in GitHub as well. So the deployer is actually running on Jenkins. We have some code based on Java, and most of the code are based on the API scriptler, Groovy scriptler, sorry. Any one of you heard about the Groovy scriptler? Okay, it's actually a way you can script some code, put it inside the Jenkins repository, and call it with parameters. So you had the code all in one place, and you can just simply use it in your job. And the deployment engine is based on Ruby. So when we run the Jenkins, we had a view for each team, and each team had its own permission. And when I go to the team, I can just simply choose the job by the permissions of the team and run it. Each job is actually deployment of a microservice. So we had some requirements. First of all, the requirement to hold the template for all 120 concurrent jobs. We have 200 services, but not all of them are migrated to the deployer. We have some legacy services, and we're ongoing on a process that move as much as we can into the deployment tool. But first of all, we had a requirement to hold a template, because if there is a bug in one of the jobs, I'm not going to fix it for each 100 jobs that I left. Okay, so we use, actually we hold on GitHub a JSON with definition of all jobs. It's a single JSON that's managed by the deployment team, and we hold the service name, okay, which is the name of the job, the group that needs to own the permissions for each job, and the type, whatever it's Puppet or Kubernetes, okay, and this is actually the central location. When we put a new service and onboard a new service, we just put it in this location. And as soon as it's there, we can run a DSL. DSL, it's kind of, I will talk about, this is exactly what I'm talking about. We can run a code that takes this JSON and create all services on the spot on Jenkins. It's something that runs in about 10 seconds, and all jobs are being created instantly. So if say, for example, that you find a bug in one of the jobs, it's very simple to fix it in the DSL code, run the DSL command, and then all services will get it in 5 seconds, 10 seconds, and you won't have to deal with all services. And you get a unified process, and each service does the same, and this is one of the main goals. The other requirement, okay, this is the DSL plugin. So as I explained previously, we have the seed and we have each service, and each service inherits its roles and gets the information. The other requirement is to block specific jobs from running in parallel. So let's say service A cannot run in parallel with service B. It was also a requirement. So we have a job at JSON that hold also in the GitHub repository, and the deployment team are managing this JSON job. And in this JSON job, they say this job A cannot run with job B. So if you try to run it, you will get a warning. You say, hey, wait for job B to end because it cannot run. But if you ignore it and you run build anyway, it will break your build, and you will get a notification. And so you cannot ignore it. The other requirement that we have is to block specific data centers. Let's say, for example, I want to block all data centers. Where in, by the way, this is the current status, where tomorrow, on Friday, it's a Black Friday. So no one is touching production, I think, all over the world. No one is touching production in Black Friday and Cyber Monday. So we just had a requirement. How do we block it? I mean, we're not going to turn off the Jenkins server. Or let's say we don't want to make deployments into the Amsterdam data center. So we also have properties file that hold in the same location of Jenkins, and then we can just simply define which data servers are open and which data servers are closed. And when you open a job and it's being generated the list of the data servers, it's read instantly the data centers list from the server, from the GitHub server. Okay, so I talked about it previously, but each job, it's actually a Jenkins Pipeline job, okay? There is no, it's not a normal, I mean, it's quite common. It's quite easy to understand whoever is developing it. So each job based, when we do deployment to production, we're divided into 3 steps. One of them is the control group, other deployment, and post-check. Control group, we said, for example, when I trigger deployment to production, there are some pre-checks that this service can run right now because there is no service in parallel. And let's say we have in this example 4 nodes that I want to deploy. Whatever you use, Kubernetes or Puppet, it doesn't really matter. So the first step, we deployed only a single node. And then the pipeline sends mail to the developer. The single node, this node number 1, it's being deployed. Just connect, do your test, see if everything works properly as expected. You get a mail notification. When he has something around 1 hour to check that everything works properly. And when he approves in the Jenkins UI that this node works properly. The other 3 nodes are being deployed in parallel. Users are being actually switched from this node to the other nodes. And of course, finally, when the job ends, there is also a requirement for the user to make some post checks because you're not triggering it and that's it. We want us to wait and to make sure that the deployment works and ended successfully and everything is up and running in production as expected. And as soon as we approved the check, the post check, we get a mail, and this is how it looks like. From the right side, this is the pipeline UI. If any of you are familiar with the pipeline, you know these steps. It's actually kind of a flow that you see on the Jenkins. And of course, we have the ongoing notification. And this example is where the developer gets the mail. Deployment of something is waiting for your input. Okay? Have a look. Check the single server. And finally, when the deployment ends, we're just sending a nice HTML mail with all data and logs and links to the relevant job, whatever you want to test. So this is how it looks like. The Puppet job, the job that deploy Puppet. Okay, this is actually a form that the developers fill in. Okay, we have some general information I will talk about later, but this is the general view of Kubernetes. We need less information than we need from the Puppet in our case. And of course, the feature when we trigger a job in Jenkins, so we have a lot of features. Each part of this form, it's actually coded with a lot of lines of code and a lot of calculations. For example, the general info, it's a note, a free text that the deployment engineer can put in the GitHub. Merry Christmas, for example, and everyone who opens the deployment job will get it here. Okay? The region also, if I want to deploy to Auckland or Virginia, if I want to close these data centers, I can close it from the GitHub. And then it will be generated every time that it's trying to open the job. And if I close it in GitHub, you won't be able to see it. The version, you can see only versions list of the versions that have been promoted. If you remember from the CI processes, we are promoting versions. Move from the release into the production. So you will be able to see only versions that have been promoted. And of course, the servers, we hold the data for each servers in a Puppet role, if you're familiar with it. So we hold the data for each service, and each service can expose its own servers to production. I can choose which servers I want to deploy. I can choose all servers, which is the most common, or a single server. And this is the continue of the form. Each deployment requires GitHub pull request. Okay, you familiar with GitHub pull request? Okay, so if a developer or someone wants to make a change in production, you open a GitHub pull request, and when you open the job, you get a pull request that's relevant to this job and to this data center. And when he picks up this pull request and run the deployment, by the way, you can see also the data from the pull request. You can see which file were changed in the Puppet. .pp, it's Puppet file. Okay, we can see the status of a link of the status of the pull request, if it can be merged or not, if it's whatever it's relevant. And we can also see some CI test on the pull request. When you open a pull request, you actually change the Puppet version. So we have some kind of TeamCity build that scans the Puppet version that you don't have a syntax error and everything. So everything is reflected into the Jenkins UI. And everything is coded, of course, by the Groovy scriptler. And when you trigger a deployment, the deployment ends successfully, finally it will close automatically the pull request using the GitHub API. And finally, you can see it in the Jenkins. This is, by the way, an HTML that's drawn into Jenkins UI. And it's real, okay? You can see each server that, you can see actually a shopping cart before the checkout. Checkout is actually a deployment. So you can see exactly what you chose from the form. You can see each server, the current service that deployed on him, and you can have a look and make sure if all services versions are as expected. Same for Kubernetes goes here. It's some less data because Kubernetes Docker, it contains less data that we need from Puppet. But in this case, we can just place which version we want to upgrade. We can see the status of the last deployment version. And if you want to roll back, we just simply choose roll back and press the button, and it will roll it back. We don't have to manage versions or remember what we did previously. So, okay, in the pipeline, so the next step, it's a connection to ServiceNow. Any one of you familiar with ServiceNow? Okay, so ServiceNow is actually, we manage the entire tickets and requirements of deploying to production. So it will be reading automatically issues from ServiceNow and show it in the form and close the issues in the ServiceNow system. We are working on it right now. So, so the last summary of the presentation is the impact. What did it change in our case? So first of all, we put a lot of effort to make this proper D6R a bulletproof. We make a lot of effort to develop things that prevent the developer making mistakes. And in this way, developers cannot mess with the production. Of course, that they can deploy whatever they want, but they cannot do a mistake. It's not like providing an SSH login. It's very easy. Unexpectedly, but actually we did expect it, but the developers are happy with it. I mean, developers are happy with the empowerment. They feel more accountable. They feel that they're doing something else instead of writing their code and push it. They're also running the deployment, and they own the entire process. The deployment team, it's actually moved from running deployment into developing tools for this deployer tool, maintain this tool, move into other tasks, extend their expertise in other areas. And of course, the deployment and the response for bug fixes, for hotfix, for emergency deployments is faster. You don't have to wake up in the middle of the night and wait for someone to do it for you. You can do it on your own. And finally, I think this is real DevOps is all about. Thank you very much. If you have any other questions, we have 3 minutes left. So feel free to contact me. I'm here until tomorrow evening. I'm actually here until Sunday because I have some weekend here in Munich. If you have any other question, I would be happy to answer. And thank you very much.